Alright, now that your lines are numbered, it's time to start writing the equation for each line. Okay, now as you write your equation, and I would recommend that you do the work I'm about to show you on your paper in your notebook, okay, but you're going to fill in these slides as you go, okay, so I'm going to kind of show you like what, how to write the equations here, and then also how to fill it in here. So, let's start right here. I'm going to use line 5 in my design as an example. So here's line 5. Okay, now let's look at what you're being asked for here. The first thing you're asked for in this table is the end points. The end points are the points where the lines end. So these are the end points. So for line 5, the end points are, let's see, this is 1, 2, 3, 4, 5, 6, 7, -7, -3, and -5, 3. Those are my end points. Okay, so I'm going to write them down in my notebook, and I'm also going to put them here. I'm going to kind of do both at the same time. Now I'm going to do both at the same time just because I think it's clearer to show you, but you can, I think it might be easier for you to kind of just do it all at once in your notebook and then transfer it here. Okay, so those are my endpoints. Now notice what I need. I need my slope and my y-intercept, which is of course what I need to write my equation, y equals mx plus b, right? Because once I have an m and a b, then I have the equation. Okay, so how am I going to figure out my m and my b? That's what I have to figure out. Now, there's a couple ways you could do this. For my m, I can use the slope formula, right? I can do x1, y1, x2, y2. You can always use the slope formula. Okay, and again, you might even want to write this down in your notebook, and that way you don't have to come back to the video all the time. It's up to you, right? So this is y2 minus y1 over x2 minus x1. This becomes, right, this is double negative, that becomes 3 plus 3, that's 6. This is -5 plus 7, that's 2. And I get 3. So my slope is 3. Okay, now I want to point something out to you. I could have looked at the line and just used rise over run. I could have said, okay, I'm going up 6 and over 2. And my slope is 3. Could have done it that way. Okay, so that's up to you, but you need to figure out the slope of the line. Okay, now the y-intercept. Some of the lines, like for example, if I look at line 7 really quick, see line 7? I can look at line 7 and see the y-intercept because it's right here. There, it hits the y-axis right there. The y-intercept is 3. So I won't need to do any math to find the y-intercept of line 7 because I can see it. However, for this line, line 5, I could get a ruler and try to trace it up, but the y-intercept is something way up here. So I'm going to have to figure it out mathematically, okay? But look, I have it in my head, like, it's way up there, so I don't know, it should be like, what does it look like? 15, 20, I don't know, something up there, right? Certainly shouldn't be negative or anything like that. So here's how we figure out the y-intercept mathematically. Remember, I take what I know. Okay, now what I know is I know my m, right? And I know I'm going to use an x and a y value. It doesn't matter which of these points. I could use this x and y value, or I could use this x and y value. Okay. For me, I'm going to just go ahead with this. I got a positive number in there, a little smaller. So I'm plugging in my y value is 3. My m value happens to be the same, also 3. My x value is -5 plus b. So now I'm going to multiply. I need to get b by itself. I get 18 equals b, which of course makes sense, right? I'm imagining this line going up, and it seems like, yeah, it'll probably hit around 18. So now, look, I have my b. So I have my m and I have my b. So I'm going to go and I'm going to say, okay, my m was 3, and my b was 18. And here's my y equals mx plus b. Y equals mx plus b. Now, here is where we do something called a domain restriction. Okay, and I'm going to show you why we do it. Okay, and so far, here's what we know. We know that I needed to find the slope. I could do that either on the graph, or I could use the slope formula. We needed to find the y-intercept, which, again, some of these lines you're going to be able to just do it off the graph. Some you're going to need to do the math. Now look, like see for this line, like line 9, like line 9, yeah, you might need to do the math, or you could just kind of see the y-intercept. Oh, it's going to be right here. So you can cheat a little bit, right? But for certain lines, you're going to need to just do the math to find the y-intercept, right? And this is how you do it. So you have all the math kind of shown over here on the right, but you might not need to do this math for each problem, because for some of the problems you might just look at it and say, oh, I can just look at it and see the slope, or I can just look at it and see the y-intercept. Okay, now the domain restriction, this is something new, and here's what it is. So let's say I write my equation y equals 3x plus 18. Now, that's a big old line, right? It's a long line. But I don't want the whole line. I just want this little piece of it from here to here. Okay, now here's how we do it. We say, okay, and let me just clean up my graph a tiny bit so you can really see what I'm about to do here, because this is brand new information for you. I'm working with line 5. Okay, so it goes from here to here. Now, what I want to do is tell Desmos, I don't want this whole line, right? That whole line is like this whole line. I don't want that whole line. I just want this piece of it. I want the piece that goes from here to here. And so what I'm going to do is I'm going to cut it, and I'm going to use these x values. I'm going to say, okay, I want that line, but only from this x value to this x value. So that's 1, 2, 3, 4, 5, 6, 7. So I want this line, but I only want it from -7 to -5. Okay, and here's how I write it. I use these little funny brackets. Okay, they're kind of like just below like the backspace on the keyboard. And I'm going to put -7. Okay, and here's how we write it. We write less than or equal to x less than or equal to -5. Okay, now this is always the smaller number. Okay, it's the one on the left, right? You can see like the -7 was the left side of my line. And this number is the larger one on the right side of the line, right? It was over here. And so if I now type this into Desmos, so I'm going to just take a look at this formatting, right? You put it next to the line. So I'm going to put a space. I'm going to get my little funny bracket, -7, and watch, I'm going to type less than, it's next to m, and then the equal to sign, and it just gives me that less than or equal to x. Now notice what it did. It cut the line at -7 right here. Is less than or equal to -5. And that is my line. Right now it's a tiny bit hard to tell because this graph is just like a little bit set up differently, but we can see, right? It's going from, look, -7, -3 to -5, 3. That's our perfect line. So we did good. So this is what you're going to do for each line. Okay, so you're going to go on your picture, you're going to do the work. Now remember, for some of the lines, you're just going to be able to look at the slope and look at the y-intercept, so it might be not too much work. And then you're going to do the domain restriction, so I'm going to go here and type it here as well. So -7, and watch, you're going to just copy this. Less than or equal to x, I'm pasting less than or equal to -5. Okay, now you can actually even just, like, if you want to do this, right, if you want to do it once, watch, if I type this, I should just be able to even paste it here. Right, and there it is. I need to make sure to put it into brackets. And there it is, right? Okay, so that's everything. This is like the trickiest step, right, that you might need some help on. But try to reference this video before asking for help. okay, or ask each other.